Hello and good morning. We're going to wait another minute for others to join, and then we'll begin. Welcome to the latest installment of the Aras Innovator Demo Series. Today, we're going to see Interrogate products using Dynamic Product Navigation. The demo series runs for 30 minutes and features all demo with no sales pitch. Each installment showcases a different capability of the Aras platform. During the webinar, everyone is on global mute. If you have any questions, please submit them in the questions panel within GoToWebinar, and we'll answer as many as possible in our Q&A session at the end. This demo is being recorded, and when the recording is available, you will receive an email with a link so you can share it with your colleagues or review it again for reference. We have on the line today Kevin Richard, Director of Product Execution. Kevin, take it away.
Thank you, Brenna. Today, we will be continuing our discussion on 3D visualization, focusing on something we call Dynamic Product Navigation, or DPN. DPN refers to a suite of recent and upcoming features to improve innovators' 3D visualization capability. Our goal is to implement a framework that will enable the use of these features throughout the entire product lifecycle. This framework will provide support for custom data, custom views, technical graphics, and spatial analysis. Our approach is to implement these features in 4 key areas. With configurability, the focus is on providing support for custom data models and custom geometry display. Regarding performance, we're constantly working to improve the overall user experience and provide increasing support for larger geometry sets. Image generation allows users to capture, share, and reuse 3D imagery for collaboration or for technical illustrations. And finally, spatial search will provide a mechanism for searching or isolating part components within larger assemblies and determining spatial impacts based on part geometry and positioning. Our initial focus is on configurability. Dynamic visualization, or the process of constructing a 3D scene using query logic, requires a framework where users can determine what they want to include in that scene. The lower left area shows a key. As I explain each feature, the color depicts the status of release or development. We started by modifying our core data model and conversion capability to enable constructing 3D scenes using only the component parts positioned appropriately in 3D space. We integrated query definitions and tree grid view definitions to allow users to select the elements to render and related business objects to expose. We enabled the use of query parameters for filtering the components that get loaded. We created a software API to be used when alternate data model processing is required or for custom rendering configurations, which allow the definition of custom view modes used to highlight or de-emphasize geometry in a view. For performance, we've made continuous progress on improving the execution efficiency and speed for processing queries. We also improved the manner in which view geometry is accessed from the vault and loaded into the viewer. We're also in the process of implementing alternate server-side architectures for enabling client-server geometry streaming and for server-side rendering. Finally, we'll be including the ability for users to selectively load geometry of sub-assemblies and parts within larger assemblies. For image generation, We just completed development on the initial capability for saving and restoring views so that users can recreate a 3D scene without having to duplicate all the original steps. We have also just begun work on enabling the ability to selectively hide and show various components within a view to expose inter-assembly geometry or highlight certain components. Digital Mockup will provide the ability to load multiple assemblies that don't necessarily share a common ancestor in the BOM to, for example, support design reviews. Geometry Markup will allow users to add 3D annotations or add 3D line segments to show the placement or construction of an assembly. Custom exploded views will provide the ability to alter the position of 3D geometry within a view, for example, to illustrate manufacturing processes or otherwise communicate assembly construction. And finally, we'll provide the ability to capture a static image of a scene so that it can be used during collaboration, information exchange, or technical documentation. I will communicate more about the work for spatial search when we get closer to the implementation. Okay. So today I'm going to highlight all or many of the features that I just explained. And if you're not familiar with version 12 of Innovator, we made substantial improvements on the user interface. I went ahead and loaded a part. This is an assembly. It's a robot arm. And the typical part form is displayed up top here in an accordion view that can be expanded and collapsed. And the related items are shown via tabs on the bottom, also in an accordion view. So if you're familiar with Innovator, you'll know that we've had 3D visualization in our product for quite some time. Our intent is to provide a simplified user interface with various ways of controlling display style, the ability to show measurements on selected points, provide exploded views, cross sections, among other features. One aspect of this view, as we call it our monolithic view, is that this is a static 3D model. It is a 3D model that can be rotated and zoomed of the assembly. There's no ability to change the geometry here. On the left, you'll see a tree grid view of all the related CAD items that are associated with this particular assembly. If I select an item here, it's highlighted, and vice versa. Our dynamic visualization tool, accessed via this other icon on the sidebar, is an alternative way of viewing 3D geometry. If I hover over this button, you'll notice it says 4 dynamic views. For this particular demo, I configured 4 separate views of this particular assembly. So I'm going to go ahead and select one. You should notice immediately that the tree on the left, or what we previously called our model browser, is now using our tree grid view. Tree grid views are based on an underlying or associated query definition where users determine what information they want to expose or query in our system, and the tree grid view is one way of showing how you would like to visualize that data. In this particular query, I've created a tree grid view with 3 columns: part, state, and released. When I execute that query, I am running the query, I'm executing the query on the server, I'm getting results returned in this tree grid view on the left. And for this particular definition of the tree grid view, you'll notice I've included state and released, an indication of whether the associated part was released. So like our monolithic viewer, it's a 3D viewer. It has all the same view capabilities that we have in our monolithic viewer. But unlike the monolithic viewer, this geometry is constructed dynamically. As part of the conversion process, we extract all the various transformations for all these parts. we store them in our system, and when a query is executed, we return that data and construct the view and position the data accordingly. Also, like the monolithic view, when I select the component in the view, it's highlighted in the tree grid view, and vice versa. One of the advantages of using queries to populate the scene is that I can run filters or parameters on the query to determine or to filter the data that comes back. So one of the ways you can do that is through structure resolution. So I've opened the parameters dialog, and by default, it is showing the default or as saved configuration for this assembly. So if I select this row, you can see the options available to me. If I choose latest and re-execute the query, I am now pulling the latest or work in progress configuration for this particular view. And if you notice in the columns on the left here, I'm showing the revision and the corresponding generation. The corresponding geometry is updated based on that query as well. Likewise, I can choose to only see the latest released. When I execute this query, you'll notice that for every component in this view, the released flag is checked as true. And this will return separate geometry as well. But again, the point is that anything that's showing up in this view is directly related to the elements in the query logic defined for the underlying query definition. So in this particular case, you'll notice that there are some parts that haven't reached the release state. So the tree grid view is one way to visualize information about the assembly. Another way is to use view modes. So for this particular view definition, I've defined a view mode called state. And if I select it, what happens is that the geometry is re-rendered to show a particular color and opacity or transparency based on, in this case, the state of the corresponding component. Now, in this particular view, everything is released, so they're all rendered the same. However, if I go back to my parameters and select latest, re-render the scene, you'll notice again that the tree grid view is updated, and the geometry will reflect that update as well. Okay, and when I go ahead and select the state view mode again, you'll notice that the parts that show up in this particular query are rendered differently. That's because some of these are not in release, they're in preliminary state. Likewise, if I go back to parameters and select default, execute the query again, and re-render the view mode of state, you'll see that for this particular structure resolution, I have parts in a different state as well. In this case, the one in this mustard color is superseded. They have been superseded by some other component. Okay, so I mentioned I created several different views. I'm going to go ahead and select another one. So in this one, which I labeled part cost, you can see in the tree grid view that I have exposed different columns or created different columns and mapped different properties of the parts to this tree grid view. I've also changed the way that the part elements are rendered in the leftmost column so that they are direct links. If I select any of these, I will open the corresponding part in a separate view. So imagine a scenario where you may want to look at your product and determine ways of reducing cost. So one of the things that you can do with parameters and view modes, you can see in this particular dynamic view, I've defined a parameter called cost threshold. And you can see that it's defaulting to the value of 55 or $55. So if I go to my view state, you'll notice that I've got an additional view state called cost, indicating greater than $55. And when I select it, the view is then re-rendered to highlight, in this case in red, all the components with a cost greater than $55. I go back to my parameters and I change this value to say 100 and re-execute and re-show the view mode. You see that some of the components are now different because they have reached or they're showing a different cost threshold. Okay, if you're familiar with Innovator, at least later versions of Innovator, you know that we implemented Effectivity in our PE application, product engineering. So as a result, Effectivity is based on query definitions as well. So I created a separate view definition where I linked in the effectivity criteria dialog. And what I'm going to do is I'm going to open a separate assembly here. So if you use effectivity and are managing your assemblies by the so-called 150% BOM, you can use effectivity to visualize the assembly based on effectivity criteria. So in this particular example, I'll go back to my part form, look at the BOM structure, and you'll notice that I have, in this particular example anyway, I have two sub-assemblies, each with different effectivity expressions. I go to my view, load the effectivity dynamic view, you'll notice that I also, in this particular tree grid view, I've only exposed a single column. And I've added the effectivity criteria dialog, also possible with tree grid view definition configuration. So if I reload this view, it's a subassembly, you can see here that I have both jaw and gripper subassemblies loaded, showing the 150% BOM. If I open that effectivity criteria filter, select the scope, and select a particular effectivity date. In this case, I'll select some date early in March, apply. You can see that the tree grid view has been updated to remove one assembly and only expose the one that was effective given the date that I had chosen. Okay, I'm going to return back to the full robot arm, and I want to show another example of some capabilities we just added. If you recall, I defined these different view modes based on the structure resolution. One of the things I can do is I can go ahead and save those individual states. In this case, I went ahead and I created saved views showing the latest and default state using this same view mode. So for example, if I go back here, and select latest released, and orient my view so that it's similar to the other ones I saved, I can go into the Views tab, create a new saved view. I'll call it latest released state, save it, and then I can compare that to previous saved views simply by selecting the previously saved view. Saved views will re-execute the query. So this isn't a static image. It saves all the parameters that went into defining this view. In this case, the dynamic view chosen, the view state, any parameters that were used, and the camera position. Okay, I think we have time for one more example. So I mentioned when I was talking about dynamic product navigation that the features that we're developing can be used to navigate or identify or explore related information. So I have one more example here that I'd like to open. In this case, I've created another dynamic view. I defined my tree grid view and associated query definition accordingly. And I have just one column here showing the part hierarchy. One aspect of this particular view, however, is that I've defined a separate view mode called parts with PRs, or parts with problem reports. When I select it, the scene is re-rendered, and you'll notice that there are certain components here that are rendered in yellow, whereas everything else is transparent. If I select one of those components, the corresponding part is highlighted in the tree, but the reason why these are rendered the way they are is because there is an associated problem report, or in this case, an associated corrective action plan. And when I select the link, I'm brought right to the corrective action plan item, and I can deal with it accordingly. So that's one way of using 3D visualization to access related business items. Okay, I think that's all we have for today. Thank you.
Okay, thank you, Kevin. So if you have any questions, make sure to enter them into the questions panel. I see that we already have a few submitted. So Kevin, do you want to get us started with the first question?
Great. All right. So let's see. First question, when will the other features you mentioned be available? So yeah, I mentioned a lot of functionality that we've already implemented, sort of, or in the process of implementing, and then things that we have in our near-term roadmap. So you'll notice this more and more when we have these discussions about functionality that we talk about in regards to our roadmap, is we will identify things that are sort of in progress and things that we have sort of in our backlog. One of the benefits of an agile approach, and we switched to this about a year and a half ago, is that we're incrementing smaller pieces of functionality on a smaller cadence of releases. Okay, so a lot of the features that we implement or are in the process of implementing may be just pieces of functionality that we're trying to get out the door sooner, collect feedback, and readjust our roadmap accordingly. To answer the question, we won't necessarily give a specific service pack unless it is in active development right now, but you get an indication of that when we talk about things, for example, as being in our backlog or near-term plans. Second question, can I use query parameters to select parts to display? So actually, yeah, you could do one of two things. So I showed view modes today as a way of using the rendering attributes of color and transparency to sort of highlight, or in some cases to de-emphasize components. So you could create your own view modes that are triggered based on some parameter that you define, or you could use parameters to affect the conditional logic in the query, so that when you re-execute the query, you are filtering all but those which you want to see. So there's two ways of doing that. Next question, how did you configure the logic used to display the view? So I think it was in the fall that we had our previous DPN, or Dynamic Product Navigation demo series. And within that webinar, and you can look at that, look at our website for that information if you want to see a recording, I went through exactly how I do that, how I use query definitions, how they're defined, how I then construct a tree grid view. So how do I want to visualize that information in the left tree grid view, as we call it? And hopefully that will give you the information that you want there. Can the BOM associated with a certain dynamic view be saved separately? The BOM associated with this certain dynamic view, if I understand the question correctly, so anything that we're displaying is based on how you've constructed your bill of materials in Innovator. So when you run a query, you are actively using the structure that is defined already. Within that structure, and as part of conversion, we extract transformation data out of the native assembly files, and we use that as a way of reconstructing the scene dynamically. So I don't know if that answers the question specifically, but if it doesn't, please reach out to me. You'll see, you have my email here right on the screen. So I'll try to address that further if necessary. Can I use item types that I created in the tree grid view? So yeah, I think I showed a couple examples of that. Um, when you define a query definition, you can also pull in all sorts of related information at various levels. And when you set up your tree grid view, you determine of those what you want to display. So in the last sort of test demo scenario, I showed you the pipe bomb, and then I also included related corrective action plans, and associated with the corrective action plan is a problem report, by the way. And I just chose, just for this particular demo snippet, if you will, just to include the corrective action plan. I can include lots of information if I want, and they're directly linked to the corresponding items that are linked into the 3D view. Monolithic versus dynamic, which is best for me? So yeah, we've had monolithic viewing for quite some time, and basically what that is a it's a static representation of the assembly as it was brought into Innovator. And we've had also past webinars about how that process works, right? We have a number of various CAD connectors, and you can, through working within the CAD system, check in, if you will, or add and create the corresponding CAD items and part items within Innovator. And it's through that process that all this view geometry gets created. And it's also through that process, through separate background conversion capabilities, that we take information from various CAD systems. We support a number of them, and convert them all into a single view format. So you can view data within a single view from NX or CATIA or SolidWorks because they're all converted into a single viewing format. And that information is then brought into our dynamic viewer.
Kevin, we have time for about one more question.
One more question. Okay. How did you define view modes? That is probably a question that I'll need to answer in another session, or maybe we can do that separately. We have a whole with the latest release. There's a whole updated documentation set that talks about how we incorporate other data and how users can define view modes as well. Thanks, Brenna.
No, thank you, Kevin. And thank you all for your questions. For any we didn't get to, they'll be addressed directly within the next few days. Before you go, I'm going to leave you with our upcoming demo series topics. On June 4th, there will be a demonstration on engineering change, the digital thread in action. And on June 25th, there will be a demonstration on an innovative approach to managing simulation using Aras Innovator. You can register for upcoming demos and view any past demos at aras.com/demo series. We'd love for you to join the Aras community at community.aras.com. There, you'll find blogs, community projects, and forums, all with a lot of great information. Be sure to connect with us on LinkedIn, Twitter, Facebook, and Instagram, where we share the latest updates and news, product information, and more. We thank you for joining us today and look forward to having you visit next time. Have a great day.